Good morning, everybody. Subject advisor in the Motao district for grade 8 and 9 mathematics. Today we'll be doing your square roots and cube roots in fractions. Before we start, let's remind ourselves of that operation order. You still remember we always deal with what is in the bracket, then your powers, exponents, or roots. Orders. That O stands for order. Order, which is powers, exponents, and your roots. And of course your multiplication, your division, multiplication, addition, and subtraction. And you always move from left to right. Let's check this one for starters. We've got 1 1/3 plus 1 4/5 multiply by minus 2 over 3 all squared. Now, according to our rules there, we deal with what is in the bracket. And then what is in the bracket, it's squared. It's squared. Therefore, it's your 1/3 plus 1 4/5 multiplied by minus 2 over 3 multiplied by minus 2 over 3. Remember, last time we spoke about multiplication or division of negative and negative will give you a positive, or negative divided by negative will give you a positive, but negative by positive, negative takes over. So in that case, your negative by negative, which is going to give us negative by negative positive, which is 4 over 9. Then 1/3 plus 1 4/5. So we have dealt with the bracket. We have dealt with the exponents. All right? Now, it's still the same number, but it's easier to work in the same format. Where we'll change this to our proper fraction from improper. And what we normally do is a 3 multiplied by 1. It's a 3 plus a 1. It's a 4/3. Same thing here. 5 multiplied by 1. It's a 5 plus 4 is 9/5 by 4/9. Right, remember your bottomers. Remember your bottomers. All the time. Rules in maths. Rules. So we start this side. 9 by 4, it's a 36. But maybe there's another way of simplifying it, because you know, anyway, in maths we're always looking for simplifying of things. Then we'd say, how many 9s in 9? 1. How many 9s in 9? It's another 1. Therefore, 1 multiplied by 4 is your 4. 5 multiplied by 1 is your 5, plus 4/3. 4/3. So applying all those rules, following all the rules, all the time. Remember, the mission in maths is simplifying, solving problems. It looks that big, so many, but now it's into two now. Into two now. Remember, we said we'd be dealing with fractions. Now, taking our fraction, let's take our fraction to the next page. Next page. Your LCM is very important here. Your denominator, which is your lowest common multiple. Normally, or another way you can say the product of this, which is a 15. 3 by 5, which is a 15. That could be your LCM. Right? Another way is you make both denominators 15. Both denominators 15. So in this particular case, we say 4 over 3. Denominator here, it's a 15. 5 by 3, which is a 15. 5 by 2, which is a 15. Not 15. But now, because you have included a 5 that was not there, it should be 5 over 5, which basically means 5 over 5 means a 1, which is how many 5s in 5s? 1. How many 5s in 5? 1. 1 over 1 is a 1. So 5 over 5 means 1. It means then the 4/3 did not change at all. Same approach this side. 4/5, we want to make it 15. If you want to make it 15, you multiply it by 3. Same applies there. You also say 3 on top, which also means 3 into 3 is 1, 3 into 3. So it's 1. So mathematically, this has not changed. It's still the same because 3 over 3 is 1. So this remains the same. 5 over 5 is 1. So it remains the same. Now, applying your mathematics now. 4 by 5 is a 20. 3 by 5 is a 15. 4 by 3 is a 12. 5 by 3 is a 15. Therefore, like we said earlier on, our LCM, which would mean 20 plus 12 is 32 over our LCM, which is a 15. Which is a 15. Further on, taking it to improper fraction, how many 15s in 30? 2 of them. In 32, there are 2 of them, and the remainder is 2, which is 201 over 5. You still remember where it comes from. This is where our question comes from. Applying the rules, making things the same to work at them, applying your BODMAS, this is the situation, which is what mathematics does at its best, simplifying. But in simplifying, in solving problems, you need to follow the rules. And then you follow the rules, you have to learn the rules. So in solving problems, in simplifying, you have to follow the rules. The rules help you in simplifying and solving problems. Therefore, if they are important, then we need to learn them. Let's look at another question. 1/3 minus 2. 1 1/3 minus 2 1/2. Everything squared over half plus 2/3. One thing that you have to remember is that maths is a step-by-step process. It's a step-by-step process. Again, our friend BODMAS. What is BODMAS saying? Work in the bracket. After the bracket, you go to your powers or exponents or roots. That order. So we work within the bracket. Let's see, we work within the bracket, which means, what is the situation in the bracket? That's your half. That's your 2/3. Let's see what is happening in the bracket. Again, in a proper fraction, 3 multiplied by 1 is a 1. Plus 1 is a 4. So it gives you 4/3. Once more, 2 by minus 2 is minus 4 plus 1. 5 over 2. Remember, like we said, maths is a step-by-step process. Maths is a step-by-step process. Now, we work within, we want to simplify what is in the bracket. Before we go to your exponents, you want to simplify what is in the bracket. Again, you still remember our LCM here, 3 by 2 is 6. Therefore, you take this 2 this side to give you 6. But remember what we said earlier on. We said 4/3 multiplied by that 2, which is a 2 over 2. Minus, again, 4 minus 5 over 2. We're going to multiply it with that 3 to get a 6, or to get our LCM 6, 3 over 3. Remember the impact. This is a 1. Therefore, when you multiply with 1, this thing stayed the same. This is a 1. When you multiply with 1, stayed the same. All squared over. Again, let's work at this one. It's also 2 and 3, which is a 6. 2 and 3. But to make this 6, multiply by 3, multiply by 3 to give you a 6. 2 by 3 is a 6. But remember, 3 over 3 means 1. Same thing here, minus, 2/3. We want to make it this a 6. Therefore, we're going to multiply top and bottom by 2. Remember what it means. It means a 1. Right. Which should mean, going on top, 4 by 2 is 8 over 6. Minus 5 by 3, it's a 15, also over 6. Going to the bottom, 1 multiplied by 3 is a 3, 2 multiplied by 3 is a 3 over 6, plus 2 multiplied by 2 is a 4, 3 multiplied by 2 is a 6. Remember that one is squared. Remember that one is squared. Right? It's squared. Okay, taking it up here, 8 minus 15 is your minus 7 over our LCM, which is a 6. 8 minus 15 is your minus 7 over our LCM, which is 6. Remember, still squared. 3 plus 4, it's a 7 over our LCM, which is a 6. Right? That's where we are now. Remember where it comes from. This is where it originates. And doing maths, we simplify, we are solving problems. We only manage to do that correctly if we follow the rules. Therefore, it's very important to always remember and apply your rules. Boatmas, we've sorted what is in the bracket now. Now we remove the bracket by say minus 7 over 6 multiply minus 7 over 6, everything over 7 over 6. Minus 7 over 6 multiplied by minus 7 over 6, everything to 7 over 6. Remember, negative by negative, negative multiplied by negative will give you a positive. But let's also remember 7 over 6 is the same as 7 over 6. Therefore, that means 1, then you are left with 7 over 6. You still remember where it comes from? Where is it now? This is where it's come from. What's this? Deal with what is in a bracket. Sort out what is in a bracket. You end up with this. Add this one, these fractions, you end up with this. Therefore, those were our fractions, how we deal with our fractions, just reminding ourselves. Now let's see fractions in squares and square root. But before we get there, let's remind ourselves of what is a square. Remember, you must observe, learn, make your conclusion, analyze, and have a pattern. Just a reminder of a square. 1 multiplied by 1 gives us a square which is 1. 2 multiplied by 2 gives us a square which is a 4. 3 multiplied by 3 gives you a square which is a 9. Therefore, it means, okay, 4 multiplied by 4 gives you a square which is a 16. Right. So a square is formed by the twins. A square is formed by multiplying number by itself. A square, there is a twins that form a square. There are these twins that form a square. In other words, what is the foundation? What forms a square? It's this number. And then when we say what forms, what is the root, then when we say the square root of 1, it's a 1. Square root of 4, it's your 2. What forms it? Square root of your 9. What forms the 9? The twin, which is called a square root. Square root is a root that forms. Right? Square root of a 16. What forms your number 16? It's a 4. Therefore, square root of 16 is 4. Right? It's a square and a square root. Same applies here. 1 multiplied by 1 multiplied by 1 gives you 1. 2 multiplied by 2 multiplied by 2 gives you 8. 2 multiplied by 2 is a 4. 4 multiplied by 2 is a 8. Therefore, here we see things like triplets. There are 3 of them. And this number is called a cube. Cube, square, cube. 1, 2, 3, cube. 1, 2, 3, cube. 1, 2, 3, cube. Square, 1, 2. 1, 2 square, 1, 2 square, 1, 2 square. So looks like our twins and our triplets. 4 by 4 by 4 gives you a cube number which is called 64. So same thing. This is a sign for cube root. What is that foundation number of a 1? It's this one. What is a cube root of 8? What forms that 8? It's your 2. What forms that 8? It's your 2. Right? What forms that 27 as a cube number? It's your 3. Therefore, cube root of 27 is 3. What forms the cube root number 64? Is of course your 4. Now we are reminding ourselves. Understanding a square and a square root. The roots give you the square. You multiply the roots, they give you a square. You multiply the roots, as themselves gives you a square number. Roots 3 times give you a cube. And therefore, whatever forms those numbers, they're of course called roots. They're called your roots. Let's see now the cube roots. The cube roots. Let's see fractions in cube roots. Fractions in cube roots. Let's start with this one. It's a warm-up. 16 over 25 plus 9 over 25. Bottomers. What is bottomers saying? I don't have a bracket. Exponents, roots. I'm on the second one, all exponents. Therefore, I have to deal with that exponents. But I work within that exponents. Remember, this sign means a square root. Therefore, square root. Remember your LCM. The denominator is the same. Therefore, our LCM is 25. Remember that. Then if we've got the LCM, then we can add your numerators. In this particular case, it's 25 and 25. Remember, mathematics is a step-by-step subject. You would be given your 1 mark or 2 marks for getting that right. Right? Again now, from within, you can say, oh, 25, how many 25, 25, 1. How many 25, 25, 1. Therefore, square root of 1. Square root of 1. Square root of 1, which is A1. Which is A1. So, your rules of fractions. Your rules of fraction, look for LCM. The idea is to make it into one thing, simplify, make it into one thing. That is what maths for, simplifying problems. But remember your rules. Remember your rules. Then that equals to 1. You only go to 1 if you apply and learn and remember your rules. Okay? Let's give another one a try. Let's give another one a try. Square root of 16 over 25 plus square root of 9 over 25. Until it's internalized, the board must keep on writing it until it's just part of your nature system. Now you don't have to write it. But I'm reminding you, always remember the rules. Remember the rules. Now the square root, when they say the square root, they are looking for the twins. They are looking for the twins. They are looking for the twins. Which twins make 16? 4 and a 4. Which twins make it 25? 5 and a 5. Plus, which twins gives you 9? 3 and a 3. And which twins gives you 25? It's 5 and a 5. Now they are looking for that square root. What forms your square numbers? It's your 4. What forms that square number? It's a 5. Plus 3 over 5. Square root, square numbers. Square numbers, square root. Square numbers, square root. Square numbers, square root. Square numbers, square root. Remember our LCM. Therefore, it will be 4 plus 3 is 7 over 5. Then how many 5s into 7? 1, and you are left with 2 over 5. Learning, knowing, understanding your rules will take you from here to here. Here, the squares and the square root. Here, the fractions. That's why we said we'll be doing fractions within square root and cube root. LCM. That's where we are. All right? Let's go on to the next question. Let's go on to the next question. Remember, don't get intimidated of how big the question is. What is important is if you understand. This one is already saying cube root, that sign, cube root. In other words, you are looking for those triplets. For those triplets. Bracket, square root, your twins, plus 1. That's the situation. Mathematics is a step-by-step process. Right. We start with what is in the bracket. On 25 over 27. And then we know to change division to multiplication, or we can't do that as yet. We must deal with what is in the bracket first, according to Bodmer's. You see, you get tempted, but you cannot do anything before you deal with what is in the bracket. Remember cube root. What is a twin there? It's your 2. What gives you a square number 4? It's a 2. What gives you a square number 9? It's a 3 plus 1. So we are still the rules, step by step. Mathematics is a step-by-step process. From here. Don't look at the complex, just look at and just follow your rules. Remember your rules. Right. Against our fractions, in a bracket, right? LCM, our friend, LCM. LCM. Remember, 1 means 1 over 1. Therefore, LCM here, we need an LCM of 3. It means you multiply this by 3 and that's by 3. But basically, 1 means 3 over 3. Step by step process is mathematics. Mathematics, like life, like anything in life, step by step process. Alright? Okay, cube root. We'll be looking for those tuplets. We'll get there. But before we get there, we need to simplify what is inside here. So now, by removing our bracket, is 5 over 3. You see, by removing the bracket, it's a process of simplifying. Using your BODMAS, it's steps of simplifying. Step by step, piece by piece. I don't want to say mathematics is an elephant that you eat it piece by piece, but like I said, like any other thing, you follow the rules. And voila, as they say, things are clear, right? Minus 125 over 27. Remember, when we change our division sign, we also invert. In other words, your denominator becomes a numerator and your numerator becomes a denominator. Remember that. Mathematics is a step-by-step process. What always frustrates most of us, we want to see the final answer. You have to do it step by step. We'll get there. They say there's a nationality that say a journey of 1,000 miles was started with 1 step. That's life. That's what it is. Right. Now, cube root minus 125 over 27 multiplied by 3 over 5. Now it's multiplication. We don't have brackets, but we must work within this. We can take it as our roof. Within this house, we must sort out what is in this house, and when we're ready, we can get out of this house. Now we'll say, okay, how many 5s in 5? 1. How many 5s in 12? 2 of them. And the remainder is 2. And then how many 5s in 25? There are 5 of them. Same thing, how many 3s into 3s? 1. And how many 3s in 27? 9. Applying our rules in simplifying. Therefore, you are left with minus 25 over 9. Minus 25 over 9. Do you remember where it comes from? Here is where we started the journey. We are nearing our destination. But remember the rules. Remember the rules. Follow the rules. BODMAS now, it's in our system. Let's see here. 12, 25, 3 and 9. Okay, I think this was copied, not copied correctly. Apologies for that. It's your square. It's your square. It's your square. It's your square there. because it's looking for your twins. It's looking for your twins. Apologies for that. Which means, once more, you are looking for twins. What make your twins there? Alright. It's 5 and a 5, and 3 and a 3. Therefore, in this particular case, because you need to have -5 and -5, therefore, the only thing that you can take out there, which makes your twin there, is a 3 square root. 3, this one you can't take it out. Mathematically, it's undefined. It's a negative. We cannot have a square root of a negative number. Right. That is the situation with number F, the one of -125 over 27 divided by 5 over 3. Right. Okay, let's go to the next one. 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 I know the situation here is most of you will be taking these lessons as recordings. Therefore, when you deal with them, you won't take 2 hours like I'm doing. You'll be taking your breaks, playing it, and making a follow-up, and so on and so on. So in this particular case, I will not take a break. You also, when you play it there, when you get your tapes, you'll make your breaks, or rewind and see and repeat, so that you can see whether we are still following each other. We are still following each other. -1 over 3 cubed -1 over 8. Again, you look at it. Where do you start? What is BODMAS saying? What is BODMAS saying? Right? Where do we start? You don't have a bracket. You have got an exponent. Let's work within that exponent and see what happens. And see what happens. And see what happens. And see what happens. So we start inside there. Inside there, we change our fraction to the proper fraction. 4 by 12 is 48. 48 plus 1 is 49 over 4. Like I said, your mathematics, it's a step-by-step process. -1 over 8. Right? Again, we work out with exponents. What is happening here? Or the roots. So again, this is a square root sign. It's looking for your twins, which is 7 by 7. So square root of 49, it's a 7. Twins, that makes 4, is a 2. Square root of 4 is your 2. Alright? This one, it was transcribing error. That's the situation there. Then you will have your minus 1 over 3 by 1 over 3 by 1 over 3 when you remove your brackets. That's what it means. 1/3 and a third multiplied by a third. That's the situation. Again, let's change that one into a common fraction. 8 multiplied by 1 is an 8 plus 1 is a 9 over 8. Remember, mathematics is a step-by-step process. That's what matters. The final answer will come. You should not always worry about the final answer, because that's where we make mistakes, because you say, this one, it looks like I won't get to the final answer. I won't arrive at my destination. Step by step. Step by step, patience is the name of the game. Right? That's where we are now. Remember where we come from? This is what we got out of this. This is what we got out of this. This is what we got out of this. All right? Now, square root 7/2. Let's remove that bracket. 1 by 1 by 1 is a 1. 3 by 3 is a 9. 9 by 3 is a 27. Minus 9/8. Minus 9/8. It's your fraction. They've got denominators. Then we're going to look at your LCM. Remember earlier on, that's what we said about LCM. Multiplying that by this will give you LCM. Therefore, to multiply by everything, because 2 is a factor of that, therefore we'll use 27/8. 27/8. 27 multiplied by 8, which is 8 by 7, it's your 56. 8 by 2, it's a 16. Plus 5, 216. Right. Therefore, what do we do to get that LCM? 216 divided by that 2. 216 divided by that 2. 2 into 21, 10 times. Or 2 into 2, 10 times into 1, 0, into 16 is 8. Therefore, we'll be multiplying by 108. Remember, we want 216. 5 by 3, it's your 15, it's your LCM. 216, that's the situation. Now we come to this one as well. It means you'll say 27 by 8, which is 216, but up and above to get a 1. Remember, 108 gives you a 1. 8 and 8 gives you 1. Minus 9, 27, 8 by 27. Sorry about that, I was just trying to get you an LCM here. Because at grade 9, we are not encouraged to use calculators. We are not encouraged to use calculators. And our multiplication, we know this one is 216, minus your LCM here is 216. 1 by 8 is 8. Minus, so let's start with this one. 108 multiplied by 7. 7 by 8, 56. 7 by that, 0, and a 5 is 7. So it's 756. and then 9 by 27. 27 by 9. 27 by 9, okay, run out of space here. 27 by 9, 9 by 7, 63, 9 by 2, 18, plus 3, 243. Therefore, that is your 243. But I'm sure in cases like this, you can be allowed to use your calculator as long as you don't make everything using your calculator there. Therefore, minus 243 and a minus 8 is 11, 5, 2. Therefore, you'll be having 756 over 216 minus 251 over 216. Again, 756. Let me put it on another page. Otherwise, it might be confusing. Let me just transcribe it to another page. 756 over 216 minus 251 over 216. All right, it's onto that page. Then you say, okay, 756 minus 251. 6 minus 1 is 5. 5 minus 5 is 0. 7 minus 2 minus 5, which means minus 505 over 216. Right. That's the situation there. For now, let's see 216. Let's use our ladder. Let's use our ladder and see what we get out of 216. 216. 216. You start with your prime factor. You start with your prime factor. 2 into 2 goes once, into 1, 0, into 6, 3 times. Right. And then the 2, the 3 there does not divide, the 4, the 5. So this one as well would be ending there unless if there's a mistake somewhere in the question. But basically, that is using your squares, your fractions within your square numbers. Your square numbers. Let's just take, let me just write some questions down for you, and then we'll take a 10 minutes break. Let me just do some questions and see whether we're following. Let me just leave some questions here, and then we'll be going to decimal fractions. Let's see, 11 over 16 minus 1 over 8. That's your first one. The second one, square root of cube root of 8 over 27 minus 5 over 9. The second one. Then the third one, cube root of 1 over 64. Okay, let me just see. All right, yeah, those are the 3 questions. Those are the 3 questions. Now let's take a few minutes break while you're still working on those, and we'll come back on them. Let's take a break, Baba. Thank you. Good morning again. Before we continue, I asked you to do, apologies, there was a question that I did not record properly, but this is how it is. Let's fix that one. But the focus here is, let's see what happens within our rules of both mass that we're talking about. Right. Exponents, according to Botmas, or brackets, let's start with brackets. Divide, let's deal with this bracket. Right? Let's deal with this bracket first. Let's deal with the bracket first. So in that bracket, the square root, the number that makes a 4 a square, it's a 2. The number that makes 9 a square, it's a 3, which is called a square root, plus 1. Again, remember, dealing with our fractions, we still have to work in the bracket. We spoke about LCM earlier on. We know 1 means 1 over 1, and to make denominator 3, multiply denominator by 3 and numerator by 3. Therefore, it will be 2 over 3 plus 3 over 3. We are still working in our brackets. Which is, of course, because of LCM, is your 5 over 3. Right, now we have sorted out the bracket. Now from the bracket, we still have to work into the power, the cube root now. Again, what makes the number minus 125 is minus 5 by minus 5, which is minus 5, and then what makes 27 is 3 and a 3 and a 3, which is a 3 divided by 5 over 3. 5 over 3. Right. Again, we know when we work with fractions, we change the division sign to a multiplication sign. Therefore, it's minus 5 over 3 multiplied by 3 over 5. Now, it comes to a finality because now, like I said, apologies, it was not correctly copied. 5 into 5 is 1, 5 into 5 is 1, 3 into 3 is 1, 3 into 3 is 1, and then you are still left with a negative sign, which is negative 1. Negative 1. Remember where it comes from. Remember where it comes from. This is where it comes from. Solving in a bracket, the square root. What forms 4? What makes 4 a square number? It's a 2. What makes 9 a square number? It's a 3. Now what is your final answer? Is minus 1. But like I said, step by step, you work out in a bracket, like we did there. We sorted out the bracket first, and then we end up with 5 over 3. Then you go to your exponents, you end up with minus 5 over 3. But remember, understanding what cube root means. Cube root means what forms that cube number. It's your minus 5 in this case. What forms that cube number? It's your 3 in this case. And then it ends up being minus 1. Minus 1. All right. That is the one that was not correctly copied, and then the other one, just fixing those two. Let me make sure this time is correctly copied. Yes, that's the situation. Right. Again here, your rules. No brackets, no, we're left with roots, radicals, or powers, or exponents. Right. Now we start with this one. And if they're of the same thing, power and exponents, you start from left to right. If it's an addition and subtraction, you start from left to right. If it's division multiplication, you start from left to right. Now there's the situation here. But now remember, we have to start inside the big one. The pieces that makes the big one. That's where we have to start. Now, we change it into a proper fraction. 4 by 12, 48 plus 1, 49 over 4. Like we said earlier on, mathematics is a step-by-step process. Right? This one, removing the bracket, is 1 over 2 by 1 over 2 by 1 over 2. Let's put it in a bracket. And then we change that one. 8 by 1 is 1, 1. 8 by 1 is an 8. 8 plus 1 is a 9 over 8. 9 over 8. Step-by-step process. Step-by-step process. The issue is not really the final answer. Now we start again now. All right? What is the situation here? What makes a 49 a square? It's a 7. What makes a 4 a square? It's a 2. Right? We've got minus 1 multiplied by 1 multiplied by 1 is a 1. 2 multiplied by 2 multiplied by 2 is an 8. Minus 9 over 8. Minus 9 over 8. LCM here is the same. Now we want to make that one to be the same. To make it to be the same, you must multiply 2 by 4. Like we said, 7 over 2 multiplied by 4 over 4. Remember, 4 over 4 is a 1. Minus 1 over 8 minus 9 over 8. All right? And then 7 multiplied by 4 is 28 over 8, minus 1 over 8, minus 9 over 8. Now we've got our LCM, common multiple, lowest common multiple. We've got a commonality which is an 8. Now let's see. 28 minus 1, 27. 27 minus 9 is what? 18. 27 minus 9. 17 minus 9 is an 8. It's your 18, right? 18 over 8. That's where we are at the moment. Okay. Now, let's see what makes 18. Or should we go to the ladder? Or the factors of 18 is 2 and a 9. Factors of 8 is 2 and a 4. 2 and a 4. 2 and a 4. All right. Therefore, we've got the square root of 18, which is 2 multiplied by 9, over the square root of 2 multiplied by 4. Again, we still ask that question. 2 is not a square number, right? And then what makes 9? What is the square root of 9? Is 3. We take it outside. 2 we can't, right? Again, we say square root of 2 is a 2. A 2 is not a square number. It does not have a twin. We leave it inside. But what is square root of 4? It's a 2. Right? Which gives you what? Inside the square sign is 2 over 2, which is a 1. And square root of 1 is 1, which is 3 over 2. Or again, another way of simplifying, another method of simplifying is factorizing. Factorizing is one of the strategies of simplifying. let's say we've got our 18 over 8, right, which is equals to 2 multiplied by 9 and 2 multiplied by 4. You took out your common factor there. In other words, 2, how many 2's into 2? 1. How many 2's into 2? 1. Therefore, you are left with 9 over 4. Right? Square root of 9. What makes a number 9 a square is a 3. What makes number 9 of 4 a square is a 2. Which is the same kind of. Those two were not correctly copied now. That's why they come to that finality. Let's say, where did it start? Where did it start? Where did it start? This is where it started. From here to here. From here to here. So by using the rules, by knowing the rules, by following the rules properly, by knowing your rules, by understanding your rules, you would know when and how to apply your rules, and therefore you'll be able to get to the correct answers. Now we can quickly go back to our the exercise that I left you with. Remember, we are working with fractions, right? We are within that. Now we look for the LCM. This is 16. We want also this to also be 16. Then you can say, okay, 16 divided by 82. Therefore, you're going to multiply by 2 to get 16. Minus 1 over 8 by 2 over 2. There's our LCM. We're looking for an LCM. 11 over 16 minus 2 over 16. Now fractions, LCM, remember step by step. Changing that to LCM, that's a situation. We've got an LCM, we've got commonality, so your denominator is 16. Therefore 11 minus 2 is your 9. It's your 9. The question remains, what makes this 9 a square? It's a 3. What makes this 16 a square? It's a 4. Therefore, that question takes you here. All right? Let's also do this one. Squares and okay, this one before you go further is also a cube there. It's a cube there, sorry. It's a cube there. The main guy is your square there. But now the question remains, what makes this a cube? It's your 2. What makes this a cube? It's your 3. Then we have removed that, but within the exponent. Oh, your square root minus 5 over 9. That's where you are. Step number 1, we remove that cube root sign. That's your 1 mark for that, or your 1 step, not necessarily 1 mark. That's your 1 step, because I said mathematics is step-by-step process. Now you check here. You've got 9. What would be your LCM? LCM would be 9. How do you make 3 to be 9? You multiply it by 3. Therefore, say 2 multiplied by 3 multiplied by 3 over 3 minus 5 over 9. All right? 2 multiplied by 2, 4 over 9. And then minus 5, it's 6 over 9 6 over 9 minus 5 over 9. 2 by 3 is a 6. 2 by 3 is a 6. Okay? Right? We've got commonality here, your LCM, which is 9. 6 minus 5 is a 1. Now that question stands again. What number makes 1 a square? It's a 1. What makes 9 a square? It's a 3. So, from this question, let's put it this way. From your question, this question, there's your final answer. Simplify, applying rules, LCM, removing the square root sign, the cube root sign, etc. Right, let's finalize with this one, and then we'll be going to decimal fractions within the square root. And right, we start inside the house. The cube root is the main guy. Now the question is, what number makes 1 a square? It's a 1. What number makes 64 a square? It's your 8. Right? There we are. Like I said, step by step, square root of 1 is 1. Square root of 64 is 1. Like I said, step by step. Now, what makes 1 a cube is a 1, which is 1 by 1 by 1. What makes 8 a cubed? It's a 2, which is 2 by 2 by 2. So from this one to your half. From this one, but let's also, so that we cannot leave some of us behind, let's remind ourselves of the use or how the ladder assists us. I'll redo this question so that I can remind you of a ladder. Let me redo that question so that I can remind you of a ladder. In other words, using our ladder, we used your prime factors. Your lowest one is 2 here, if you remember. You say, how many 2's in 3 into 6? 3 of them. How many 2's into 4? 2 of them. Again, 2 is an even number. How many 2's into 3? 1, and the remainder 1. How many 2's into 12 is 6. Right? Then, how many 2's in 16 is 8. How many 2's in 8 is 4. How many 2's in 4 is a 2. How many 2's in 2? 1. Remember, when we're looking for a square, we are looking for twins. So, this will give you one twin, this will give you another twin. So 2 by 2 is a 4, 4 by 2 is an 8. 2 by 2 is a 4, 4 by 2 is an 8. Hence we said, okay, the situation here is a square root of 1 over 64 is 8 by 8. And that one is 1 by 1. Hence we say, okay, what makes 1 a square is a 1. What makes 64 a square is an 8. And then that's why we further said, okay, what makes 1 a cube is a 1, and what makes 1 8 and cube is a 2. So sometimes to remind yourself to make your factors, to make your cube numbers or square numbers or cube root or square roots, you can go to a ladder, because remember, in 9, 8, and 9, we are not as yet encouraged to use the calculator. Let's go to decimal fractions now in closing our questions. Let's go to decimal fractions. Let's go to decimal fractions. Let's go to decimal fractions. Let me just make sure that these questions were correctly copied. Yes. Your first one is 3 cube root of 0.125 plus square root of 1.21 multiply by 0.2 to be squared. Never ever forget your bottomers. Never ever forget your bottomers. Therefore, we remove the brackets first. Or rather, the advice here, we have done common fractions already. We have done common fractions, we understand LCM, we know how to solve this thing, these questions using for common fraction and resorting to LCM. Therefore, the advice here would be change them to common fractions. And this is what we do. We want to make this one fraction a whole number. Therefore, we move a decimal comma. Let's move a decimal comma. 1, 2, 3. Therefore, 125 is a whole number. But because we move decimal comma 3 times, we'll say divide by 1,000. In other words, we moved it 3 times, we're going to use 3 zeros. Same approach here. Let's change it to common fraction. To common fraction, yes. Same approach here. We want to make this one a whole number. We move a decimal comma 2 times. 1, 2. Therefore, it's 121. How many times did you move it? 1, 2. Same thing here. We want to make this one a whole number. How many times do we move it? Once. Therefore, we've got minus 2. Then we divide by. That's the situation now, because now we have done our common fractions. It will be easy to revert back to what we know. Right? Again, same approach. We are going to start with bracket. We are going to start with bracket. Right? Therefore, we are going to say this minus 2 over 10 multiplied by minus 2 over 10. We want to remove brackets and let them be in the same situation so that we can. Same situation, same language so that we can deal with it. Cube root of 125 over 1,000 plus square root of 121 over 100. Multiply, remember negative by negative becomes positive. Negative by negative becomes positive. Therefore, it's 4. 10 multiplied by 10 is 100. Like we said, your step by step. Step by step. I think the ladder here will assist. The ladder here will be very useful. Of 125. Let's check what 125. 125 and 11. We'll check 125 and 121. 125. Let's go there. The lowest prime factor is 2, but 2 is not dividing into this. The next one is 3. 3 into 12 4 times, but in 5 it does not divide. The next one is 5. And because your last number is 5, therefore it's divisible by 5. How many 5s into 12s? 2. And then we've got a remainder of 2. How many 5 in 25? 5 times. How many 5s in 25? 5 times. How many 5s into 5? 1. Therefore, your 125 is 5 by 5 by 5. And your 1,000 is 10 by 10 by 10. 10 multiplied by 10 multiplied by 10. All right? Okay, let's write it properly here. And then we can also check your 121. 3 does not divide, 2 does not divide, 5 does not divide. Therefore, the next one is 11. How many 11s into 12? 1 means 1. How many 11s into 11? 1. How many 11s into 11? 1. Therefore, 121 is 11 by 11. Therefore, let's write it properly. He said cube root of 125, 5 by 5 by 5, 10 by 10 by 10. Right? Plus 121 is 11 by 11. 100 is 10 by 10. Multiplied by 4 over 10. Remember, according to Botmas, we have to work first powers out. But we now understand what a cube root makes. What makes 125 a cube root is your 5. What makes your 1,000 a cube root is your 10. What makes your 121 a square is your 11. What makes your 100 a square is a 10. Multiply by 4 over 10. Botmas. Multiplication comes first. Therefore, we deal with multiplication first. 11 by 4 is 44 over 10. And our fractions, there is our LC. There is our common multiple, lowest, which is a 10 in common, and then 44 plus 5 is your 49. How many 10s is 49? 4, and then remainder 9 over 10. 9 over 10. 4 9/10. Where does it come from? That's very important to always remind ourselves. This is where it comes from. This is where it comes from. 4 9 over 10. That's our question. So advise, change your decimal fractions into common. Decimal fraction into common fraction. Now, the next one. Now, if you must copy these questions correctly. Cube root of 0.02 squared plus minus 0.01. Botmas, what is Botmas saying? Botmas saying remove the brackets. But before that, my advice was let's change it to our common fractions. Let's change it to decimal to common fractions. We want to make this one a whole number, so we want to make it a 2. Yes, remove the decimal comma once, therefore we'll put 10. But remember it's squared. Plus, minus, we want, how many times do we move our decimal comma? 1, 2, 3, therefore it's a 13, and we divide by 3 zeros because we move our decimal comma 3 times. Now, bottomers, let's remove the bracket. It's 4 over 100 minus 13 over 1,000. 13 over 1,000. Right? Like we said, remember, maths, it's a step by step. It's a step by step process. That's what matters. Right? Our LCM now. Our LCM. 1,000 divided by 10 gives you 100. Therefore, you're going to multiply numerator and denominator by 100. Because remember, 100 multiplied by 100 divided by 100 is a 1. Minus 13 over 1,000. Cube root 400 over 1,000 minus 13 over 1,000. Minus 13. Just want to check whether I copied it or correct. 1, 2, 3 is 1,000. And then 2, 4 over 100. You see now, this is why I made a mistake. I could pick it up. It's a 2 multiplied by 2 is a 4. 10 multiplied by 10 is a 100. It's a 100. It's a 100. It's a 100. It's a 100. Okay, I'll just do it this side. Therefore, cube root 4 over 100 minus 13 over 1,000. Your LCM, 1,000 divided by 100, it's a 10. So multiply everything by 10. So 4 multiplied by 10 over 100 multiplied by 10 minus 13 over 1,000. Which is cube root of 40 over 1,000 minus 13 over 1,000. Minus 13 over 1,000. Step by step, as you say. So our common LCM is 1,000. 40 minus 13, 27. 40 minus 13 is 27. What makes 27 a cube number? What makes 27 a cube number? It's a 3. What makes 1,000 a cube number? 10 by 10 by 10 is a 10. Therefore, from here, to here, from here to here, by following the rules. Following the rules, change them to common fractions. 2 multiplied by 2 is a 4, 10 by 2. Remove the brackets, your LCM, and then that's where you end. That's where you end there. Okay, let's take another question. And of course, make sure it's correctly copied. 0.01, 2, 3, 4, 1, 2, 3, 4, 5. 4, 5 zeros. Yes. Now I said our approach here, let's change our decimal to common fractions. Yes, you still remember. Let's take it's minus here. Let's change it to common fraction. Let's move our decimal comma. 1, 2, 3, 4, 5, 6. We moved it 6 times. So it's 1 over, 6 zeros is a million. 6 zeros is a million. 6 zeros is a million. Cube root, let's see the square root of this. What makes 1s square? What makes 1s square? It's a 1. What makes a million s square? It's 1,000 by 1,000. 1,000 by 1,000. Your twins, 1,000 by 1,000. Right. What makes -1 a cube root? Is -1 by -1 by -1 by -1 by -1 gives you -1. What makes 1,000 a cube? 10 by 10 by 10. It means it's a 10. So from here to here, from this one to this one, from that one to that one, okay. Let's see whether we understand the square. We understand from decimal to common. Let's apply deeper now. We'll be doing, or before that question, I'll close with that one. Let me go to this one and see how well you're doing with your fractions. 3 2/5 divided 3 4 7 divided 0.35. Remember, we have to change it to a common fraction from mixed fraction. 5 by 3 is 15 plus 2 is 17 over 5. Divided 7 by 3, 21 plus 4, 25 over 7. Divide, change it to a common fraction, to a common fraction. We move it 2 times. 1, 1, 2, 35. Yes, you divide it with 100 with 2 zeros. Right? 17 divided by 5. Remember, we change division to multiplication. We also invert. 7 goes up and 25 comes down here. Multiply, 100 goes up and 35 comes in. So the signs are the same. The signs are the same, then you start from left to right. Left to right. Let's see how many 25s in 25, 1. How many 25s in 200? 4. How many 7 into 7? 1. How many 7 into 35? 7. Therefore, we'll be having 17 by 4 over 5 by 7. 5 by 7, which will be 68 over 35. How many 35s there? 1. And then what is the remainder? 33 over 35. Okay. Before we go to the next one, let's check this one. Okay. Would you be able to do this one? What did we say? We changed to a common fraction. And then we deal with it. Decimal comma 1, 2, 36. How many times? It moved 2 times. What makes 36 a square? It's a 6. What makes 100 a square? It's a 10. A 10. A 10. A 10. A 10. All right. Now this will be the last one for the day. This will be your last one for the day. Let's see now when we go to algebraic expressions, can we also implement? Let's see. In other words, what you have learned, can you use what you have learned here? Plus 0.01 x to the power 8. What was my suggestion? Let's change them first to common fractions. How do we do that? Let's move the decimal comma. How many times? 1, 2. Therefore, it's 3, 1, 2, x to the power 8. We want a whole number. How many times do we move the decimal comma? 1, 2, over 1, 2, x to the power 8. We have our LCM. We have our commonality, which is 100. 3 plus 1 is 4, x to the power 8. Same approach. What makes a 4 a square? It's your 2. What makes your 100 a square? It's your 10. What makes x to the power 8 a square is x to the power 4 by x to the power 4, which is your final answer. Thank you very much. I hope you've learned something, a lot. Remember, life is rules and maths is life. Therefore, maths is rules. For you to solve problems, you need to apply the rules. And for you to apply those rules, you must learn how those rules apply. Good luck. Thank you very much.